Internet Protocol. The Internet Protocol, or simply IP, is the principal communications protocol in the Internet Protocol suite for relaying datagrams across network boundaries. This function of routing network packets enables internetworking and essentially establishes the Internet. IP is the primary protocol in the Internet layer of the Internet Protocol suite and has the task of delivering packets from the source host to the destination host solely based on the addresses. For this purpose, IP defines datagrams structures that encapsulate the data to be delivered. It also defines addressing methods that are used to label the datagram source and destinations. Historically, IP was connectionless datagram service in the original transmission control protocol introduced by Vint Cerf and Bob Kahn in 1974, the other being the connection-oriented transmission control protocol. The Internet Protocol suite is therefore often referred to as a TCP/IP. The first major version of IP is the Internet Protocol version 4, IPv4. We learned in addressing is the dominant protocol of the Internet. Its successor is Internet Protocol version 6 or IPv6, which is increasing in use. The Internet Protocol is responsible for addressing hosts and routing datagrams packets from a source host to a destination host across one or more IP networks. For this purpose, the Internet Protocol defines the format of packets and addressing system that has two functions: identifying hosts and providing a logical location service. Each datagram has two components, a header and a payload. The IP header is tagged with the source IP address, destination IP address, and other metadata needed to route and deliver the datagram. The payload is the data that is transported. This process of nesting the data payload in a packet with a header is called encapsulation. Addressing entails the assignment of IP addresses and associated parameters to host interfaces, and the division of the address space into networks and subnetworks, involving the designation of network or routing prefixes. IP routing is performed by all hosts, but most importantly by routers, which transport packets across network boundaries. Routers communicate with one another via specially designed routing protocols, either interior gateway protocols or IGPs, or exterior gateway protocols or EGPs, as needed for the topology of the network. IP routing is also common in local networks. For example, many Ethernet switches support IP multicast operations. These switches use IP addresses and Internet Group Management Protocols or IGMPs for controlled multicast routing, but use MAC addresses for the actual routing. The design principles of the Internet protocols assume that the network infrastructure is inherently unreliable at any single network element or transmission medium, and that it is dynamic in terms of availability of links and nodes. No central monitoring or performance measurement facility exists that tracks or maintains the state of the network. For the benefit of reducing network complexity, the intelligence in the network is purposely most located in the end nodes of each data transmission. This is expressed in the end-to-end principle of Internet design. Routers in the transmission path forward packets to the next known directly reachable gateway matching the routing prefix for the destination address. As a consequence of this design, the Internet protocol only provides best effort delivery, and its service is characterized as unreliable. In network architectural language, it is a connectionless protocol, in contrast to so-called connection-oriented modes of transmission. Various error conditions may occur, such as data corruption, packet loss, and duplication, as well as out-of-order packet delivery, because routing is dynamic, meaning every packet is treated independently, and the network maintains no state based on the path of prior packets. It is possible that some packets are routed on a different path to their destination, resulting in improper sequencing at the receiver. Internet Protocol version 4, IPv4, provides safeguards to ensure that the IP packet headers is error-free. A routing node calculates a checksum for a packet. If the checksum is bad, the routing node discards the packet. The routing node does not have to notify either end node, although the Internet Control Message Protocol (ICMP) allows such notification. In contrast, IPv6 abandons checksum in favor of faster processing of packets during routing. All error conditions in the network must be detected and compensated by the end nodes of a transmission. The upper layer protocols of the Internet Protocol Suite are responsible for resolving reliability issues. For example, a host may cache data to ensure correct ordering before the data is delivered to an application. The dynamic nature and the diversity of the Internet and its components provide no guarantee that any particular path is actually capable of or suitable for performing the data transmission requested, even if the data path is available and reliable. One of the technical constraints is the size of data packets allowed on a given link. An application must assure that it uses proper transmission characteristics. Some of this responsibility lies also in the upper layer protocols. Facilities exist to examine the maximum transmission unit or MTU size of the logical link, as well as for the entire projected path to the destination when using IPv6. The IPv4 internetworking layer has a capability to automatically fragment the original datagram into smaller units for transmission. In this case, IP does not provide reordering or fragments delivered out of order. The transmission control protocol, about which we will talk later, is an example of a protocol that adjusts its segment size to be smaller than the MTU. The user datagram protocol, it's a UDP, about which we will talk later, and the Internet Control Message Protocol, ICMP, disregard MTU size, hereby forcing IP to fragment oversized datagrams. In May 1974, the Institute of Electrical and Electronic Engineers, IEEE, published a paper entitled Protocol for Packet Network Telecommunication. The paper's authors, Vince Cerf and Bob Kahn, described an internetworking protocol for sharing resources using packet switching among the nodes. A central control component of this model was the Transmission Control Program or Protocol, TCP, that incorporated both connection-oriented links and datagram services between hosts. The monolithic Transmission Control Program was later divided into a modular architecture consisting of the Transmission Control Protocol at the connection-oriented layer and the Internet Protocol at the internetworking datagram layer. The model became known informally as TCP/IP, although formally referenced as the Internet Protocol Suite. Internet Protocol is one of the elements that define the Internet. The dominant internetworking protocol in the Internet layer in use today is IPv4. The number 4 is the protocol version number carried in every IP datagram. IPv4 is described in RFC 791, which was published in 1981. The successor to IPv4 is IPv6. Its most prominent modification from version 4 is the addressing system. IPv4 uses 32-bit addresses, while IPv6 uses 128-bit addresses. Although adoption of IPv6 has been slow, As of June 2008, all United States government systems have demonstrated basic infrastructure support for IPv6. IP versions from 0 to 3 were development versions of IPv4 and were used between 1977 and 1979. Version 5 was used by the Internet Stream Protocol, an experimental streaming protocol. Version number 6 through 9 were proposed for various protocol models designed to replace IPv4. SIPP, or Simple Internet Protocol Plus, known now as IPv6. TPIX, or PIP, and TUBA. Other protocol proposals named IPv6 and IPv4 briefly surfaced, but they had no affiliation with any international standards body and have had no support. On April 1 in 1994, the IETF published an April Fool's Day joke about IPv9. It's an out of lessons. During the design phase of ARPANET and the early Internet, the security aspects and needs of a public international network could not be adequately anticipated, and consequently many Internet protocols exhibited vulnerabilities highlighted by network attacks and later security assessments. In 2008, a thorough security assessment and proposed mitigation of problems was published, and the Internet Engineering Task Force has been pursuing further studies.